Hello guys, good morning. How are you all? Guys, can you hear me? Why isn't anyone coming yet? I mean, the class just completed right now, the previous class.
Yes, sir.
Yes,
Okay,
sir.
fine. Fine. Anyways, we'll start. What happened yesterday? I didn't get a class link. Was there not a class yesterday? I don't know. I'm at home.
We had a class, sir.
Okay,
Yes,
they
sir.
might have.
The class.
Who took the class? Hello?
So we forgot the
I
name.
don't remember the name.
So someone else took the class?
Yes, sir. Surname
And
starts with H.
Yes, sir.
what's his name?
I don't remember.
Sir Harris, I guess. Harris.
Harris.
Sir. Yes, sir.
Okay, fine. Nice. So yeah, let me continue. Did he teach anything specific?
Yes, sir, about
No, sir, we
distance.
gave one numerical about resistance, about Ohm's law.
That's it. Okay. Done. So I'm sharing my screen. I hope you played with that simulator that I gave that day, right? I mean, the website that I asked you to check, play with some resistances randomly. Did you check it?
Yes.
Yes, sir.
So can I give you some, like, can I start with some random questions and give you some numericals on these things?
Yes.
Yes,
Yeah.
sir.
So just give me a second. I'm sharing the screen. Yeah. So to start with, I'm sure you can do a problem which is as simple as this, where you simply have a battery and a resistance. This is something that anybody can do, right? Guys, can anybody just give me the answer? Like if I give 10 volts of battery voltage, 5 ohms resistance, what is the current flowing in it circuit?
2 ampere.
Like because it is direct, right? 2 amps. Simply all you need to do is like 10 by 5 and it is 2 amperes. This is all good. This is very simple to do. But what if I have more batteries? Like what if I have a case like this? uh 10 volts, 10 volts, 4 ampere, 4 ohms. What is the current now?
5 ampere.
Yes.
How do you know?
Like 10 plus 10
Adding
by
10
12.
plus 10.
Why did you add them?
Battery's voltage.
Okay, fine. What is the case now? If I have something like this and like this, 4 ohms, 10 volts, 10 volts. What's now? What's the current now?
4.
Current is different, sir. At
Is it
every
different now?
aspect. Yes, sir.
What's the difference between this case and this case?
Sir, it's parallel and it's
One is parallel and the other is?
One is in series.
So, okay, so this is what I want to discuss. I mean, for a simple problem like this, the first problem, anybody can give an answer. It is very simple. V equals to IR. Everybody knows this formula, which is Ohm's law. That is there in your school. Everybody knows about Ohm's law. So V equal to IR, you can easily find the value of current, which is equal to 10 by 5 and 2 amperes. It is not that big of a deal. Okay. But what is the case when there are multiple resistances, multiple batteries connected in different shapes? To understand that, like if we give a problem where can anybody give an answer to this case? I give multiple resistances, multiple batteries, all
you cannot
connected in
see
a
your diagram.
what?
You are writing something, but we are unable to see it.
The screen is sharing, right?
Yes, sir.
We can
Yes, sir, we can see.
Sorry, it's me.
Thank you. So if I have something like this, 5 ohms, 5 ohms, 5 ohms, 10 volts, 10 volts, you can't really say like it's not that simple to solve a problem like this. Okay. So to understand these things, you need to understand some other concept before which I'm going to discuss. Just give me a second. Guys, just give me a second, okay? Yeah, I'm sorry. So that is where we need to discuss something called series and parallel. Series and parallel connections. Can anybody give me a practical example of series and parallel connections? Can you?
Sir,
Parallel in
manages
our home, sir.
The series
Yeah.
connection we
In
use in
street
some
lights, sir.
lights.
Series.
functions.
Okay, so the street lights. Let's start with the street lights. Let us start with that only. I already have drawn the street lights the other day. I'll try again. So the street bulbs, they're connected like this. Are they in series or are they in parallel?
Series, sir.
Series.
Are you
Series.
sure?
Yes.
So if one of the
Parallel.
bulb is gone, the entire circuit is gone.
No, sir.
Yes, in series it is gone.
No, you people tell me, is it series or parallel?
Sir, I guess parallel because in our street lights, if one bulb is
Parallel.
gone, others are not there.
Sir, in series, if one does not work,
Sir,
then
it is
all
series,
others
sir.
will.
Sir, series is fairy light, sir.
Sir, it's series, sir.
Is it series for sure?
Yes, sir.
What is the scene with like these like whenever they decorate a house with these serial lights?
In Ganesh Chaturthi, sir.
Yeah, in Ganesh Chaturthi.
Series.
Sir, that
Or
is series, sir.
They are in series. Are you sure?
Yes,
Yes,
sir.
sir.
Let's start with even something simpler. The battery is in the back of a remote. We have batteries that are connected in the back of a remote, right? Like this.
Yes,
Can anybody tell me whether they are in series or parallel?
they are in series.
In parallel, sir.
So they are in series.
Now, to understand which one is series and which one is parallel, first I believe you should understand what is series and what is parallel. Okay. Now, please try to understand, just because I put two elements like this, they are not parallel. Okay, the connection doesn't have to be parallel. So let me just put it very simply like this. In series connection, the things, like, no matter how they are, if they're connected head to tail and head to tail and head to tail and head to tail, this connection is a series connection. You get my point?
Yes.
If I have a parallel connection, for the same case, I'm drawing the same arrows, but if I join all the tails at once, it is difficult to join all the tails, but I'll try. And all heads at once, point A and point B. Here it's called as point A and point B. In between A to B, this is a series connection. In between A to B, this is a parallel connection. Do you see that? Do you understand this, first of all?
Yes.
It doesn't matter how the bodies are the components or electrical elements, they can be of any shape. You can quite literally have any shape that is possible. But the only thing that you need to understand, whether they are joined head to tail, head to tail, head to tail, or just all parallelly, like all heads are at once and all tails are at once. Let me give you an example. Let me take three resistances. Are they series or are they in parallel?
We cannot tell right now.
We still can't tell because we didn't connect them. Now they are connected like this.
Series.
Series.
Yes, very. If they are like this and I connect them like this,
Parallel.
Parallel.
now
Parallel.
that is like if you have batteries. Can you tell me which direction is it connected? Are they are series and are they are parallel? We still don't know. We didn't connect them yet. If I do this, now they are in series. Can anybody make these three parallel? Is there a way that we can make these three parallel?
Yes, sir.
How?
Can I draw?
Yeah, please. Is the annotation available? Yeah, it is available. You can draw. I mean, like, you cannot move the resistances, right? So you cannot move the batteries. Connect there only. Correct on the diagram that I made only directly.
Okay.
Who wants to try? Okay, can anybody? Bhuvan, are you trying?
Can I? Another try.
Yeah, try.
I think this is the possible. I just think
Are you
this.
sure?
Yes, but
Okay, delete it. I'll try to draw it very clearly. Okay. Right. So if you do that, all you need to do is connect all these three together and all these three together. That will be a parallel connection. That's all. It's as simple as this. Do you people understand?
yes.
Yeah. So this is one thing that you people should keep in mind, that whenever you're connecting two components or three components, whether they're in series or parallel, decided by how the ends are connected, not how the circuit looks like. Okay. I'll give you another connection. Let us see if you can check whether they are series or parallel. Uh, there are two resistances. Are they in series or are they parallel?
Series.
They are in series. That is good, because you obviously see one side is connected, but the other side, other end is directly not connected. There's a battery in between, so you can clearly say it is series, like head to tail, this to this, and then this to this next connection. So they're in series. That is good. If I give you another case, let me try to think something. Okay. Yeah, try to tell me this. Resistance A, B, C. What is in series and what is in parallel?
ABR.
AB are in series and AB to C are in parallel.
That is good. A, B are in series. These
to
two
C
are
are
in series, and this whole thing is parallel with C. That's all. Okay. That is very good. Now that you people are able to decide whether a connection is series or parallel, that is really good. I want you to know one more thing again about series and parallel. I'm not going into detail about this. I'm just giving you a very rough idea. A very rough idea. I mean, which you already might know. So I'm not really going into detail, because this is a second year topic and we only need that detail in the second year class. Not definitely not right now. So in series, if you have multiple resistances connected in series, R1, R2, R3, R4. What is the effective resistance, guys?
R1 plus
R1
R2 plus
plus R2 plus R3 plus R4.
R1 plus R2 plus R3 plus R4. That is good. But what if you have all the four resistances in parallel?
1 by R1 plus 1 by R2 plus 1 by R3 plus 1 by R4.
equals
No,
to
that
1 by R effective.
1 by R.
exactly. It should be like this. 1 by R effective equals to, a lot of people say this is the effective resistance. It's not effective. It's a reciprocal of effective resistance. Okay. So you already know this also, right?
sir.
When resistances are connected like this is how you find the effective resistance. So can I give you some problems on this?
Yes.
Yeah. Find the effective resistance in between point A and B.
5/2, sir.
Let others also try. That is a good answer, but let others also try. As you
2.5.
also check whether, yeah,
2.5.
that is good. Anyone else has an answer? Effective resistance, guys. It's very simple, right? The effective resistance of these two is nothing but in series. So you directly write them as in series. So you will, I'm redrawing the diagram with like this, because I combined these two into single resistance. So there is single resistance will be 5 ohm and 5 ohm. Now these two are in parallel. So the effective resistance of parallel is how much? 1 by R effective equals to 1 by 5 plus 1 by 5, which is 2 by 5. So if you take the reciprocal of this thing, R effective equals to 5 by 2. 2.5 ohms. You get this?
Yes, sir.
Yes, sir.
Yeah. Now, I'll give you another question. This could be a little difficult, so give it a try properly. Find the effective resistance, guys.
Five point five.
5 point what?
5.5.
Sir, it's 7.
Properly check it, guys. You need to make sure.
Sir, 7.
Are you sure?
Yeah, sir, I guess.
Now, let us try to solve it. Case one.
5.8.
5.5.
First of all,
7.5, sir.
combine these two, you will get 5 ohms. Combine these two, you will get 5 ohms. And these two. 5 ohms and 10 ohms. I'm leaving it like this. Now the effective of these two in parallel, we already have done it previously, which will be 5 by 2. What is the parallel of these two, guys? Did anybody try?
Yes.
10
How
by
much it
3.
is?
10 by
10
3.
by 2. It is 10 by 3. Yeah. This will be 10 by 3 and this will be 5 by 2. The addition, again, these two are in series now. The R effective will be
Sir,
5
35
by
by 6.
plus 10 by 3. It will be how much?
35 by 6.
Yeah. Nobody got this answer, right?
Sure.
Sir,
5
I
by
You
got,
told
2.5. And 10
sir, I
by
got
3,
35 by 6.
3.3. 2.5 plus 3.3, it's 5.5.
Acha, you gave 5.5 as answer.
Yes.
Okay, fine. Now, so I hope you get this thing. Like the finding the effective resistance. Can we move on to more difficult problems?
Yes.
Are you sure?
We'll try, sir.
Okay, fine.
sir.
Let us. Since you guys are doing well, I'm trying to give you more difficult problems. So try not to mess up. Okay. Uh, uh, mm, mm, mm.
1.5.
3 by 2, 7.5.
Sir, 1.5.
1.5. Are you sure?
Yes.
Okay, so let me clearly clarify everyone. So first of all, you have to find the parallel of these two. How much is that? Guys, make this a habit, okay? Like every time you want to find effective resistance, try to do it step by step. 1 ohm. So
Will it be
of
two?
these two, it will be 2 ohms, right? Did you get 2 ohms?
Yes, sir.
1 by 6 plus 1 by 3. If you solve it, you will get 2 ohms. And this 3 ohms, I'm just leaving it like this. So now you have to find the resistance, I mean, a series of those two, which will be 3 ohms. 3 ohms again. And the next comes, the resistance of these two will be 3/2 ohms. Yeah. So that will be 1.5. That is good, guys. You guys are doing great. Can we get into more complicated problems now?
Yes,
Are you sure?
kind of,
What?
kind of sure, sir.
Kind of sure, huh? Fine. Try this, guys. I only gave this problem because you people are sounding very confident. So let us see if you can do it or not. Next time.
Four point five.
How much did you get?
Adding 2, 3, 4, 4, 5, 9, 9, 1 by 9, 1 by 9, 2 by 9, 9 by 2, 4.5.
What? All those things are answers.
No. That process. Sir, I think it's 4.5. Sir. I'm not.
So 14 ohms. 14, sir. 14. 14 ohms, sir.
14 ohms. Are you sure?
Yes, sir.
Do you have a method for that?
So they're all connected in the series, but the ones which came like up and down, they are not there any resistors, sir.
So what will it be?
14 ohms.
But like you said, which one are parallel? Okay, solving this problem will not be your kind right now because it is not that easy to solve. You need to know things about potentials and all. So I don't want to get there. Uh, do you people know anything about Wheatstone Bridge? Hello? Do you people know anything about Wheatstone Bridge? I don't think so. Okay, fine. I don't want to give those questions also. Let me try this one. Find the effective resistance.
Sir, is it 5 ohms?
5 ohms.
5 ohms, sir.
How do you know?
Sir, because they are in parallel and that
Are you
three
sure they are in parallel?
Yes, sir.
How do you know? Kushit, how do you know that they are in parallel?
So they're not connected head to toe tail, sir.
Yeah, you can say one thing that all the resistances are connected on this end clearly, and all the tails are also connected like this. So you can say these three are in parallel. So the 3 ohm stays like this. But for the 666, you have to do 1 by 6 plus 1 by 6 plus 1 by 6 equal to 1 by R effective. You will get 2 ohms. Yeah, that is good. So the effective resistance of 3 ohms or 2 ohms is nothing but 5 ohms. You got it? You understood it? Guys, you understood it?
Yes.
Yeah, that is good. Let me try another. I'm just thinking what other ways to give you or trouble you with more questions. Yeah, let's try this. Yeah, try this.
Six ohms, sir.
1.6.
Are you sure it is 6?
6 ohms.
Sir, is it 8 by 5?
Sir, 1.6.
First of all, these two are in series. Do you agree?
Yes.
Yes, sir.
So it will be like 2 ohms. And this 4 and 4 are in series. So that will be 8 ohms, right? And the effective resistance of these two will be, hello, 1.6, right?
Yes.
Yes, sir.
All you need to do is again 1 by 8 plus 1 by 2 equal to 1 by R effective. If you solve this, you will get R effective as 1 point. That is good. Okay. I mean, you're doing actually quite good as in this case, like you have a decent idea about finding the effective resistances. I mean, there are a lot more problems where you will be very, very suffocated to do these problems. You won't be able to find answers to more cases that you can. I mean, I can ask you them, but I need to talk about potentials and all, which is not a concept right now. So, let's talk about batteries, the same thing. Series for batteries and parallel for batteries. What will happen if I connect two batteries in series? Sorry, 3 batteries in series. 10 volts, 5 volts, 3 volts. What is the effective battery voltage here?
15.
Yeah,
Sorry, 18. Sorry.
18.
18, sir.
it will be considered as directly 18. So what happens when you
Yes,
connect
sir.
them all parallelly? What happens now? Can anybody tell me?
10 volts.
No, the thing that you should be remembering is without internal resistance. There is a thing called internal resistance. We will talk about it later. Without internal resistance, this is not even allowed. But in practicality, you can do it. But in practicality, there is internal resistance. For now, you people don't know anything about internal resistance. That is why I'm not discussing this case. Without internal resistance, you cannot discuss this topic. So I'm ignoring this topic. Let us only consider the series connection case only. Okay, guys. Let's only consider series connection. Now, for tomorrow, that I need you to know one thing, that what if I have a case? You people know, right? In series, what is the same? In parallel, what is same for resistances and batteries? In series, let us just say you have 3 resistances in series. What is constant throughout?
The current.
The current on. In a parallel connection, what is constant?
Voltage.
Potential difference.
Yeah, potential difference or voltage difference is constant. I hope you already know this.
Yes, sir.
The current will be different in this case. I1, I2, I3. And the voltages will be different here. V1, V2, V3. The voltages will be different here. The currents will be different in parallel. But can you people find the answers for something like this? If I give you a question where there is a 10-volt battery, uh, 6 ohms, 3 ohms, and 1 ohm. What is the current through the circuit? What is the voltage across each resistance?
Current will be 1 ampere.
Yeah,
1
sir.
ampere.
1 ampere. What is the voltage across each resistance?
Six,
Same.
Same, sir.
5 by 3 over the first one.
Yeah.
sir, voltage is equals to current into resistance. So in first case it would be 6, second case 3, third case 1.
1.
Yeah, sir.
It will be first case. What will be the
It will be 6.
6 volts, 3 volts, and 1 volt? Are you sure?
Yes.
What if the problem gets complicated? I'm giving you another question here. Let us see if you can do this now. 2 ohms, 2 ohms, 1 ohm. I gave a 20-volt battery. Can you give me the currents and voltages now?
Sir, 884.
Current is 4.
Okay, some people seem to know about this, and some people seem not having any idea about this. We'll do one thing.
4
Since
amperes.
So
yeah, yeah.
16, 16.
No, it is not 16. It is 884. Tushit, was it you who answered it?
No, sir.
The 4
Okay, fine.
ampere.
Okay, it's totally fine, guys. I mean, some people don't know. I think some people are struggling about this specific case. So what I will do here is I will give you some ideas about this in tomorrow's class. Today it will be difficult because the time is almost over and I can't complete the entire thing in the time left. That is just like 10 minutes. So I will discuss these voltages and currents case tomorrow. And before that, if you didn't understand the previous cases also, please let me know. I will try to deal with some cases there also. Okay. So I hope you understood the previous part, but this part will be slightly difficult to understand the voltages and all. I will discuss that in tomorrow's class. All right, guys.
Sir,
And I
when
will,
will offline classes start?
what?
Sir, when will offline classes start?
In the month of June, right? Like they didn't give you a date yet.
No, they didn't.
No, they will eventually give you a date because they will
Sir,
probably
2nd
start.
June.
Yeah, sir. 2nd June.
They gave you a date as 2nd June.
Yes, sir.
Yes, sir.
Then it's good. It's good. But I'm not sure. I'm not exactly sure about the date. But yeah, you guys, whenever the date is given to you, people try to be there on that date. Okay. All right,
Yes, sir.
guys. Yeah. So thank you very much. We'll meet again in tomorrow's class. Thank you very much. Bye bye.